Now we'll discuss about mesh analysis, the procedure to be followed in order to solve the mesh analysis problems. We are going to see now. The first step is identify the number of loops in the given circuit. Identify the number of loops in the given circuit. After identifying, assign for all the loops either the current direction in clockwise or anti-clockwise direction. And then apply the first KVL, then Ohm's law next. We will be getting mesh equations. Now we are going to see a problem on mesh analysis. For the circuit shown below, find the mesh currents and also current flowing through 4 ohm resistor. Now, the first step to be followed here is identify the number of loops. Therefore, we can say that here two loops are present. Step 1, the number of loops is 2. Step 2, assigning a current direction for each loop. I'm assuming that both the currents are flowing in clockwise direction. Even we can assume that both the currents are flowing in anti-clockwise direction also. Okay. Now I'm gonna apply the third step, step 3. Apply KVL to loop 1. What do you get? We know how to apply KVL. KVL is nothing but in any lumped electric circuit at any time t, the algebraic sum of the voltages around the loop is equals to 0. So if I apply KVL to the first loop, either we can follow starting direction or ending direction. As we can see here, the current is flowing here clockwise. We can say that in presence of source, the current through always RLC element enters at positive terminal and leaves at negative terminal. Therefore, I start from 8 volts here. The starting sign of 8 volt is minus 8. By Ohm's law, voltage across the resistor I into R. Therefore, it is going to be 2I1. And if you notice here, the 4 ohm resistor is common for both the loops. Therefore, we are supposed to write here 4 into I1 minus I2, that equal to 0. If you notice here, the I1 is flowing in, coming in this direction, and I2 is coming in this direction. We assume that since we are applying KVL to loop 1, we assume that I1 is, dominating I2. Or if you go with the direction of I1 as it is in clockwise direction, we supposed to write here I1 minus I2. So I can simplify this. 4I1 and 2I1, I get 6I1 here, and then minus 4I2. If I take 8 to the right hand side, becomes plus 8. Name it as equation 1. Now, KVL to loop 2. If I apply KVL to loop 2, we can start from any component, or suppose we can start from this voltage 6 volts itself. If you look at the starting direction of the voltage source here, it is positive, so plus 6. And similarly, 4 ohm is common to both the loops. Now I'm applying KVL to the second loop. If you look at the direction of the I2 is like this. And I1 is coming in opposite direction. Therefore, I supposed to write here plus 4 I2 minus I1. and then one more resistor 2, and current flowing through the 2 ohm is I2. Therefore it is 2I2 equal to 0. If I simplify this, I get minus 4I1 plus 6I2 is equal to minus 6. Name it as equation 2. Now we have two equations, 1 and 2, and we are supposed to find out two unknowns. So by elimination method, I can eliminate any one of the variable, either I1 or I2. Therefore, I can find out any one parameter. And by substituting that parameter in any one equation, we can get other parameter. Now I'm going to solve equation 1 and 2. If you look at the coefficients of I1 and I2 here, I mean in equation 1 I1 and I2 and equation 2 I1 and I2, here we can see 6 is their coefficient for I1 in equation 1 and here 4 is there. So what we can do means equation 1 we can multiply with 4 and equation 2 we can multiply with 6. Therefore, if I multiply equation 1 with number 6, what do we get? 36 I1, and then if you multiply with 4 we get 24 I1 and then 16 I2, that equal to 32. What do we get? Equation 1 multiplied by 4 implies 24 I1. Since we are multiplying with 4, 6 for the 24, 4 for the 16, I2, and 8 for the 32. Similarly, equation 2 just multiply with 6, therefore it becomes 6 for the 24, 6 6 the 36, and 6 6 the 36. What do we get? Minus 24 I1 plus 36 I2 is equal to minus 36. So plus 24 and minus 24 will get cancelled. And here we get, what do we get? 20 I2, because if you subtract 36, I mean 16 from 36, we get 20. That equal to 32 minus 36, we get here minus 4. Therefore, I2 is minus 4 by 20, which is minus 1 by 5 ampere, which is minus 0.2 ampere. Now, substitute I2 value either in equation 1 or equation 2. Therefore, we get I1. I'm going to substitute in equation 1. Substitute I2 in equation 1. So what do we get? Minus 6 into I1 minus 4 into I2 equal to 8. Therefore, 6 into I1 minus 4 into I2 is 0.2 minus 0.2, that equal to 8. So you get 6I1 equal to, it is going to be 8 plus minus of 0.8, because 4 into minus 0.2 we get minus 0.8. It is going to be minus 8 minus 0.8, you get 7.2. Therefore, I1 equal to 7.2 divided by 6. So 7.2 divided by 6, what do you get? 7.2 divided by 6. It is 1.2. So we get 1.2 ampere. Therefore, I2 is minus 0.2 ampere and I1 is 1.2 amperes. The second question that I asked is, the current flowing through 4 ohm resistor Here the current flowing through 4 ohm resistor is nothing but very simple. So here the students may get doubt whether I supposed to take the current flowing through 4 ohms as I1 minus I2 or I2 minus I1. Both the answers are right. For suppose I am assuming that the current through 4 ohms is flowing in this direction. Let us say it is Ix. Simply apply KCL at this node. What do you get? Here I1 is entering and then Ix is leaving, I2 is leaving. Therefore, your Ix is going to be I1 minus I2. For suppose if I take the Ix direction upward like this, then you are supposed to write Ix as I2 minus I1. So therefore, my Ix is going to be Ix is going to be I1 minus I2. I1 is 1.2 and I2 is minus 0.2. So it is going to be 1.4 amperes.